Hi everyone, welcome to Pre-Calculus Lesson 6.4, Inverse Trig Functions and Right Triangles. In this lesson, we're going to take another look at the inverse trig functions and use triangles to find missing measurements. Now, just a reminder, an inverse trig function will give an output of an angle measure. Now, it can be in degrees or it can be in radians, but it's always going to be an angle measure. So let's see what we have to do in order for our inverse trig functions to actually work. You may recall that the domains of the functions need to be restricted so that they actually are one-to-one, meaning that they would have an inverse. So for sine inverse, we're restricting the domain to -1, 1, and the range, the output, remember we're only looking at the right half of the unit circle, which is -π/2 to +π/2, or -90 degrees to +90 degrees. Now, we are going to focus on using triangles to figure these out, so make sure you know your special right triangles for this. Now, cosine inverse has a similar domain, -1 to 1, but remember, the range is the top half of the unit circle, so it's 0 to pi, which is also known as 0 degrees to 180 degrees. Now, tangent inverse has a domain of all real numbers, so that's a little different, and the range is -π/2 to +π/2, which is -90 degrees to +90 degrees. That's the right half of the unit circle again. So remember, we're always getting a radian or degree measure for the original angle. So we need to be careful about this. Let's take a look at an example, and hopefully that'll make things a little more clear. In example 1, they want us to find the exact values for each expression, and we have to give our answers in radians, and they want us to use special right triangles to do this. So notice in part A, it says sine inverse of the square root of 3 over 2. Now, what I'm going to do is I'm going to look at my right triangles and I'm going to decide which triangle I should look at using the numbers in that fraction. They have a square root of 3 and a 2. So that's going to be my 30, 60, 90 triangle. Now, sine is opposite over hypotenuse. So I have to find an angle that's opposite the square root of 3 and the hypotenuse is 2. So notice 60 degrees is opposite from the square root of 3, and the hypotenuse is the square root of 2. So 60 degrees is what I'm looking for. But they wanted this in radians, so I need to convert this into radians. So I would just use the conversion factor, and let me show you my work. So for this one, I did 60 degrees times pi/180, and I got pi/3. Okay? So that's the answer for part A. What you're going to do is you're going to try parts B and C. So we're going to pause the video, but I do want to caution you, be careful about part B. Notice the cosine inverse is a negative number. So think about what that means. Think about what that means we need to do to our angle measure before we get our final answer. So try it, and then press play and check your answers. So what I did is I found the triangle that had both a 1 and a 2 in it, and I noticed that that was, again, my 30, 60, 90 triangle, because the 1 is here and the 2 is there. And the 1 is the adjacent side, because this is cosine, and the 2 is the hypotenuse. So 60 degrees is the angle I need. Now, remember, this is a negative value. In quadrant 1, cosine is positive, but in quadrant 2, cosine is going to be negative. So I needed a quadrant 2 angle that is equivalent, that would have a similar cosine. So I just did 180 minus 60 to get 120 degrees. Now, I did that because this was a negative, okay? Because there was a -1/2 here, that's why I converted it to 120 degrees. And that was just 180 minus 60. Now, I just changed it into radians after that to get 2π/3. Now, in part C, notice they didn't give us a fraction here, but this is the same thing as 1/1. So I need tangent inverse of 1/1, and tangent is opposite over adjacent. So looking at my triangles, I notice that in my 45, 45, 90 triangle, the opposite is going to be 1 and the adjacent is actually going to be 1 as well. So 45 degrees is the number I need. Now 45 degrees in radians is pi over 4. So that's it for this example. Let's look at another example. In this one, you'll need your calculators. In example 2, it says use a calculator to find an approximate value for each expression. Use radian mode. So in part A, I have sine inverse of 0.71. Part B is tangent inverse of 2. And part C is cosine inverse of 2. So check the mode on your calculator, make sure you're in radian mode, and then pause the video to do these questions and press play to check your answers. In part A, if I type sine inverse of 0.71 into my calculator, I get 0.78950. Now, I did round to 5 decimal places. You may have rounded differently, and that would still be okay. Part B, I got 1.10715. And part C is not possible. So your calculator would give you an error message because remember, cosine inverse's domain is -1 to +1. 2 is outside of that domain, so it's not going to work. Let's take a look at our next example. In this example, they're asking us to find the value of theta in the triangle, and they want us to give our answer in degrees. So notice what we have. We have our theta right here. We have the side that's across from it or opposite to it. And we have a hypotenuse measurement. So that's going to give you a clue as to which trig function you need to use. Now, we do need to use our calculators for this. So make sure your calculator is in degree mode. See if you can figure out how to find it out. And then press play to check your answer. So make sure you pause this video and do the work. So for this one, I typed in sine inverse of 10 over 50 because sine is opposite over hypotenuse. And you could have done sine inverse of 1/5. That would still get you the correct answer. And you get 11.5 for that. Okay, so our answer is 11.5. If you got something different, double check that you're actually in degree mode because that might be where you went wrong. Okay, so we have another example coming up. Let's take a look at what they want us to do in this one. In example 4, it says a 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle in degrees formed by the ladder and the building? So what you're going to do is you're going to draw a picture for this, label the angle that you think they need, and then try to find the angle measurement using an inverse trig function. Pause the video and do that, and then press play to check your answer. Okay, so this vertical line represents the building, this diagonal line represents the ladder, and this horizontal line represents the ground. So I have a 40-foot tall ladder. I have the 6 feet from the base of the building, and they want the angle formed by the ladder and the building. So this theta belongs up here, the angle formed by the ladder, which is the diagonal line, and the building. So that's where that belongs. Now, in order to figure this out, I need to figure out which trig function works best. So notice I have the opposite side and the hypotenuse. Opposite and hypotenuse, that's sine. So I need sine inverse of 6 over 40, which is 8.6 degrees. Now, there is another way to think about this, so let me write an equation for you. The equation would look like this. It says sine theta equals 6 over 40, because remember, when you do a sine function, it's always sine of an angle measure. So this is the equation you would have, and technically, when you solve it, you would get this sine inverse. You would do the sine inverse on both sides, and then you would just do this calculation to find out what theta is. So if I do a sine inverse on this side, it would just say theta equals, and then sine inverse on this side would be sine inverse of 6 over 40. So it's really an equation that we're making. We're solving a trig equation using an inverse function. Okay, so I have another video with a few more examples for you. Make sure you watch that. And please send me any questions you have.